wanted to welcome you to Getting the Most Out of Your Hard Seltzer webinar presented by Gusmer Enterprises. We thank you for joining us today. We have a lot to cover and we want to make sure we answer all your questions. So please enter your questions in the Q&A section or in the chat room and we'll get to them at the end. So now I'm going to roll it over to Nate Sietz.
Hey, good morning, everyone, or good afternoon for some. I'm Nate Sietz. I'm one of the Gusmer Technical Sales Managers, as well as our brewing market specialist. So thank you for joining us today. Before we get started, I just want to give a big thank you to our Beverage Marketing Director, Peter Senfert, for organizing this webinar, and Chris Nevash, who you just heard. So she's going to be our moderator, facilitating in the background. As she mentioned, we will conduct a Q&A session at the end. And if you have any follow-up questions or would like information on pricing on any of the products we discussed today, please go to gusmerenterprises.com. At the top of the page, there's a Find a Rep section. Type in your information. You'll be able to get connected with your local Gusmer technical sales rep. So with that, we'll kick it off. So I just want to do a quick overview of what hard seltzer is and what we're going to be talking about today. So hard seltzer, one of the fastest growing beverage alcohol markets in the country right now. I'm sure that's what's driving your interest in participating in our webinar today. So hard seltzers are generally made from two types of sugar bases, sucrose or dextrose, or a combination of one of the two in brewer's malted barley. They typically range between 100 and 110 calories with an alcohol percentage of 4.5 to 5% ABV. So they're really trying to achieve the sparkling water with a shot of alcohol in the background. So there is some difference between the designation of FMBs, or flavored malt beverages, and beer. And FMBs, must contain at least 25% malted barley and 7.5 pounds of hops per 100 barrels. So when you're designing your hard seltzer, please, pay attention to your local regulations and reach out to your local regulating body on, what are your guidelines in your state for producing hard seltzer. So currently the FDA or TTB does not recognize hard seltzer as a new category. So this is, particularly important to reach out to your local state regulatory body. Other types of hard seltzers, which you've probably seen out on the market, are wine or spirit based. For the purpose of today's webinar, we're only going to be talking about the production of seltzer from a sucrose, dextrose, or a combination of sucrose and dextrose with malted barley. So with that, we'll just do a brief review of the production process. So the sugar base, as I mentioned, typically sucrose or dextrose, is blended in hot water to reach your desired gravity. We're going to be talking a lot today about high gravity fermentation with our yeast and nutrients. So, that seems to be the preferred way of producing hard seltzer to get the most bang for your buck, essentially. That sugar base is then boiled for 10 to 15 minutes. And nutrients are either added in right at the end of the boil with, let's say 5 minutes to go, sometimes in the whirlpool, or right at the start of fermentation. When adding nutrients in to the boil, you don't want to do it too early in the process or have it exposed to too much heat, as you'll cause some Maillard reactions and negate the benefits of adding those nutrients in the first place. After that, the chilled base, or the base, is then chilled and oxygenated or aerated. And you would oxygenate or aerate as you would for the same beer-based gravity. So if you're doing high gravity brewing with your sucrose or dextrose, you would oxygenate or aerate at the same rate you would for a high gravity beer. Following the oxygenation or aeration, the base is then inoculated with yeast. Depending on your yeast strain and your desired, fermentation kinetics, tank temperature during fermentation typically ranges between 70 and 75 degrees Fahrenheit. With these sugar bases, we typically want to get as much alcohol as we can. So we're fermenting as low as possible, and often negative gravity is desired. And again, depending on what your fermentation kinetics, what you want to achieve with that, fermentation times can range between 3 and 10 days, and that's dependent on your fermentation temperature, your pH, starting gravity, amount of nutrients, and your yeast strain. And following fermentation, tanks are crash chilled, allowing the yeast to flocculate out. Depending on your strain, you will still need to do some sort of filtration to remove the yeast and other particulate material that may be left in there. The chilled base is then, filtered or centrifuged. And it's for hard seltzer in particular, we're trying to reach the clearest, colorless, odorless base as possible. So often carbon treatment or carbon filtration is needed to achieve that. And then when high gravity fermenting with seltzer, the finished full strength product is then blended down with deaerated water to achieve the desired ABV. And then when the ABV has been adjusted for, flavors and colorings may be added, and then carbonation can be added or adjusted during this time too. So typical packaging of hard seltzer CO2 volumes range between 2.6 and 3 volumes. So at Gusmer Enterprises, we're partnered with 2 suppliers for yeast. And of those 2 suppliers, with Renaissance and Christian Hansen, we've selected 3 strains here today that we've done internal studies with to achieve the most neutral flavor profile as possible with your hard seltzer. So we have 2 strains from Renaissance Yeast. Renaissance is a company that has selectively crossbred their yeast strains with a non-H2S producing strain. So these strains are non-GMO, and they don't produce any H2S. So that's particularly desired for seltzer production to have low sulfide production overall, but specifically no H2S production. We also have another one from our partner supplier, Christian Hansen. Their Merit strain is a nice, clean, quick fermenting Saccharomyces cerevisiae. It also has a very high alcohol tolerance, so up to 17%. And all the alcohol tolerances are listed here for all 3 strains. And in order to achieve that, it really goes into tailoring your other fermentation kinetics as far as temperature and yeast nutrient additions go, which we'll talk about later in the presentation today too. A couple things to note is the killer status. I know brewers are always interested in the killer status. So both the Viva and the Christian Hansen Merit are active, with the Renaissance Avante being neutral. We have listed our dosing recommendation here, so it's the same for all 3. So we recommend dosing these yeasts at 2 pounds per 1,000 gallons, or 28 grams per US barrel. And our philosophy behind this is with our yeast dosing recommendations, in conjunction with our tailored nutrient dosing recommendations, you'll achieve the best neutral flavor, color, and aroma profile as possible for hard seltzer production. There are a couple of key things that go into using these 3 yeast strains, and just dry yeast strains in general. So with that, I'm going to turn it over to our first presenter, Peter Sommer. He's our technology, our beverage technology director. Peter has a Master of Science degree in biology from University of Copenhagen. He also has his PhD in biotechnology from the Technical University in Denmark. Peter has worked in the wine industry for the last 15 years and has had the honor of collaborating with wineries in the US, Australia, New Zealand, South Africa, Chile, Argentina, and Germany. And then Peter's been our beverage technology director for the last 4 years. So with that, I'll turn it over to Peter.
Thank you, Nate. So it's a really important step that I'm going to talk about right now. It's making sure you take good care of the yeast that you are adding to your brew. So me coming from the wine side, we've been used to using yeast for high gravity fermentations, and that's the case here with hard seltzer. Especially when you're pushing it up towards 23 and up in Plato, you really have to be sure that all the cells you put into your brew will actually be active and do the conversion of the sugar. So besides adding the right amount of nutrients to this, which we'll talk about a little bit later, it's also important that you do two important steps, which is highlighted here: the rehydration step and the reactivation step. And the first step, as the word says, it's allow the cells to come out of that dry state. So if you're using active dry yeast or spray dried yeast, they've been dried to very low moisture content, and you need to make sure that all the vital functions of the cell get revived, especially the cell membrane. And the reactivation step is basically starting the metabolic engine and making sure that all the cells are ready to go. You can have serious problems with high gravity brews if you don't pay attention to these two important steps. Next slide. So use clean water, preferably non-chlorinated, in a clean bucket, and you add the recommended dose of the yeast in a ratio of 1 to 10. And I would say that 10 minutes, you just leave it there. Don't stir it too much at this time, but preferably if you have the time, 20 to 30 minutes is ideal. Then you can start to see that these dry pellets starts to thicken and the water is getting into the cells. Make sure that you have a thermometer so that the water temperature should be kept between 75 and 85 degrees Fahrenheit. And then at the end, you can gently mix it so you can see that most of the yeast cells are getting rehydrated. The reactivation step is also important. So when they have been rehydrated, you add the sugar source that you are going to do the final brew with in a ratio of 1 to 3, and then leave it for approximately 20 minutes. And you will start to see, the CO2 is starting. So you see bubbles on top of the vessel you're using. And that's a good sign. So that means that your yeast cells are getting ready to do the alcoholic fermentation. And then you can pump it or add it to your final brew kettle or vessel that you want to do your final fermentation in. But very important steps. Don't take it lightly. It will, you will avoid a lot of problems with stuck and sluggish fermentation if you take good care of this step.
Thank you, Peter. And with that, with yeast rehydration, reactivation as an important metric in hard seltzer production, so is the addition of yeast nutrients. So both sucrose and dextrose, very nutrient deprived. So our next presenter is Jasmine Soda. Jasmine has a bachelor's degree in chemistry from Fresno State University. She's been working with Gusmer Enterprises for the last 12 years in our research and development department. Jasmine has been instrumental in developing Gusmer's brewing nutrient line, as well as a few of our wine fermentation nutrients, including those that we'll talk about here today. And then most recently, Jasmine's worked on optimizing and developing nutrient fermentations. So with that, we'll turn it over to Jasmine.
Thank you, Nate. So when looking at nutrient recommendations and nutritional requirements for hard seltzer fermentations, it's important to know and understand what is in your base media, what is in your sugar substrate. So that is in hard seltzer, you're looking at sucrose, dextrose, and maltose. And when we analyze those three base medias, we find that they're not a good source of nitrogen, whether it's organic or inorganic. They do not have the essential trace vitamins and minerals needed for an overall good fermentation and overall good yeast health. And that's where the Gusmer complex nutrients come in. They support a good fermentation kinetic. They support your overall yeast growth. They look at, they supply those essential vitamins and minerals that are needed to ensure that you have a good fermentation and your yeast has those essential vitamins and minerals so it does not get stressed and cause off flavors, and you're able to achieve your neutral flavor and aroma and finish your fermentation in the shortest amount of time. So when you look at the nutrient profile from Gusmer, we have quite a few options, which some of them are powder, some of them are tablets. And so from going from top, we have microessential powder, which is a powdered form of yeast nutrient. It's really a complex blend which provides a rich mixture of organic and inorganic nitrogen, vitamins, and trace minerals. Then you have your microessential complete. These are our time-release nutrients. They come in tablet form, basically, and they provide, again, organic and inorganic nitrogen, vitamins, and trace minerals. Prime is our 100% organic nitrogen source. So if you do not want to add inorganic nitrogen, then 100% organic nitrogen source, we have that as a complex blend with vitamins and minerals as well. And then we have a microessential trace product, which is a pure vitamin and mineral, which you can use as a supplement to any of the other nutrients, powder, complete, or prime. All right, so for today's training, I will be focusing on high gravity brews for hard seltzer, which is anywhere from 22 to 27 degree Platos. And you'll see a few different options here as we have, these are the guidelines that we feel that we see in our benchtop studies, as well as from customers, that they provide the shortest amount of fermentation completion time, neutral flavor and aroma, and an overall good yeast health. And so with option one, you're looking at, our recommendation is 40 pounds per 1,000 gallon of microessential powder. Now for this one, we are recommending that you do 60% addition at inoculation and the remaining 40% at 48 hours. The reason for that is if you add all of the powder form at inoculation, all 100%, then during the fermentation, after the 48th or after the 50th or the 60th hour, the daughter cells will not have sufficient amount of nutrients to continue and really finish the fermentation. And it's even more critical in seltzer fermentation because the base media is very nutrient deficient. So therefore you want to have a complete fermentation, that's why we're recommending 60-40 sequential feeding of microessential powder. You look at option two, which is our microessential complete. Again, it's 40 pounds per 1,000 gallon is recommended for high gravity brews. With this, we are recommending 100% addition at inoculation. And the reason for that is these are time release tablets. So there's a built-in functionality where it eliminates the need of multiple additions and therefore sequential feeding. This ensures that you have enough nutrients and they get dissolved and they become available throughout the fermentation for your mother and daughter's yeast cells to ensure a complete fermentation and overall good yeast health. And then there's an option 3 that we have available for the high gravity brews, which is Microessential Prime, which is our organic nitrogen and vitamin and mineral mix. And for that, we're recommending 34 to 42 pounds per 1,000 gallon. Really, so you can see we have a variety of nutrients to fulfill your need for achieving a good fermentation kinetic, good yeast health, and achieve that overall neutral flavor and aroma profile. Yes, next slide, please. All right, so for regulatory compliance, as Nate talked about earlier, currently the FDA or TTB does not recognize hard seltzer as a new category. So any limitation really for beer and beer raw material would be applicable for seltzer. So we do recommend that you contact your local regulatory agency for specific guidelines to your process and to your protocol.
Thank you, Jasmine. So next, we're going to move on to our filtration recommendations. So as we mentioned earlier, Gusmer Enterprises is a manufacturer of yeast nutrients. We're also a historical manufacturer of filtration media. So our next presenter is Mui Lei. She's been a product manager with Gusmer for the last 4 years. As a product manager, she supports our Gusmer filtration media line, along with our lenticular housing line. She also supports our DuPont and BioSelect enzymes lines, which she'll touch on today too. And then prior to her role as product manager with Gusmer, she was in our R&D department for 6 years. So with that, I'll turn it over to Mui.
Thank you, Nate. Good afternoon and good morning, everybody. Today, I'll talk a little bit about filtration for hard seltzer. Like Nate mentioned earlier, for hard seltzer, a neutral base is desired. You want a neutral base that's clear. Visual clarity with a low turbidity is typically desired. Any color or flavors or unwanted aromas should be removed prior to adding flavorings, just because you don't want the flavorings to be affected by anything that's off there. Product consistency is something that consumers kind of expect from your product, especially if you're distributing it. So you want to avoid batch-to-batch variations that leave consumers kind of confused on what they're going to get. So to get a clear, colorless, flavorless, and odorless base, you typically would use filtration for that. So when customers purchase seltzer, they kind of think of a crystal clear beverage that they're going to be drinking. So you want to remove any particles that may be floating around in the final product before going to bottling or canning. This can be done with a coarse filtration step, which can remove solids such as yeast. And you want to do the coarse filtration step before using carbon media. Why is it important to do a coarse filtration step before using carbon media? Carbon isn't really intended for the filtration particles. Carbon media will remove some particles to some degree, but you have to keep in mind what you're using carbon for is to remove any color, flavor, or odor that may be in your product. So your carbon has these active sites. And if you're using your carbon to remove solids, you're going to end up surface blinding your carbon media. So your product won't actually get to the active carbon. And so you end up wasting your carbon. And yeah, it won't be fully utilized and you just have to toss it. So definitely do a coarse filtration step before you go to your carbon filtration step. On this slide, we have a couple of different filtrant media options that we could recommend for coarse filtration. Typically, a looser filter media grade such as a CSF-XC filter sheet is recommended for a plate and frame filter. If you're using a lenticular housing, we recommend one of our SoluStack lenticular filters. They come in several different grades, from from coarse all the way to fine. So we could work with you to get a coarse grade that's going to fit for your process. If you happen to use loose carbon instead of carbon media during your processing, you'll have to do a polish filtration step at the end to remove the loose carbon that's in there. With this, we would recommend using something like the CSF SP media for a plate and frame filter. If you're using a lenticular housing, we have several polished grade solute stacks that we could suggest to you as well. Now, to achieve a colorless, flavorless, and odorless product, you're going to have to use carbon. And carbon is typically impregnated into the filter media. So when you buy a sheet or a solute stack, the carbon's embedded within that media. So within that media, you'll have your carbon with its active sites. And you got to keep in mind that carbon media is not selective. It's going to remove, all forms of carbon. It's going to remove some type of color, flavor, and odor to some degree. So it's not just going to target color. It's not just going to target flavor or odor. It's going to remove a little bit of everything all at once. So you're going to have to kind of play with the carbon to see what level of filtration you may need with the carbon to kind of get your desired base. And the performance is going to depend on the parameters such as your contact time, which is related to your flow rate, the active carbon surface area, which is your sheet or stack size, and the internal specs that you have for your seltzer. Each producer is going to have their own defined specifications for what their final product should look like, smell like, and taste like. So there isn't going to be one filtration solution for seltzer. You're going to have to define it based on your final product specs. And for the carbon filtration media, we have a line called the Carbac media, which is our carbon line. And this can definitely help you achieve a colorless, flavorless, and odorless product. We offer several different grades. The 1640 HCX grade is the best choice for all around color, odor, and flavor removal. And this comes in both a filter sheet and lenticular format. If you want something that's a little bit more targeted towards color, we would recommend either the 1640 CRM or the 1640 CRX grade. And those come in either the sheet or a lenticular stack form. On this slide, we have a couple of different scenarios that you can kind of use as outlines for what to do with your finished or your near finished seltzer product. So if you're done with fermentation, you've got a product that you need to get clear, odorless, and neutral, we would recommend using the CSFXC coarse filter sheet or one of our 1925 SD lenticular cartridge filters to do your coarse filtration, and then follow that up with a carbon filtration with the 1640 HCX Carbac media. Let's say you've had a fairly clean fermentation, there's not much flavor or odor, you definitely just need to remove a little bit of color. And then we would recommend, doing maybe just a coarse filter sheet filtration with the CSFXC or one of the 1925 SD cartridge filters. And then follow that up with a 1640 CRX Carbac media grade or the 1640 CRM Carbac media grade, depending on if you're using a lenticular or a plate and frame. And if you need any help or guidance on this, please reach out to your Gusmer rep. Like Nate had mentioned, we are also a manufacturer of filter media. We're a domestic manufacturer, so we've got decades and decades of experience with filtration, and we could definitely help you. In addition to filtration, another processing aid that you could use to kind of help your process go faster and also increase throughput is enzymes. Enzymes can be used to promote faster processing and higher throughput. So one of the more common ones that we see being used out there in the brewing market right now is the alpha-acetolactate decarboxylase, or ALDC. What ALDC does, it helps shorten or eliminate the diacetyl rest time that comes after you finished or you're close to finishing your product. During fermentation, yeast cells do excrete these precursors to the vicinal diketones, or VDKs as they're called. And those eventually form diacetyl and the 2,3-pentadione compounds that can impact the quality of your product by introducing off flavors and aromas. With an ALDC like DuPont's Alphalase Advanced 4000, it works by converting those precursors, VDKs, to a flavorless compound. So you kind of bypass that pathway, and you either cut your rest or just eliminate it altogether. So with the Alphalase Advanced 4000, we recommend dosing at about 8 milliliters per barrel at inoculation. And it's very important that you dose it prior to pitching or with your yeast, because keep in mind, once again, the yeast are the ones that are introducing those precursors. So if you use the ALDC after you've pitched, there's a chance those precursors have been introduced, and you really can't get rid of diacetyl once it's formed. Next slide, please. Another option, if you are using any type of natural fruit juice or puree flavoring for your seltzers, are pectinases. These are great to help kind of depectinize and clarify any fruit juices or purees that you're using, so that you don't have any problems later on with filtration or with product stability on the shelf. Gusmer offers both the BioSelect granular pectinase that comes in a 250-gram pack, as well as DuPont's liquid pectinases, which come in the 20-kilo pails. Depending on the type of volume that you're using, you're looking to process, we can work with you to figure out which type of enzyme would work best, depending on what you're doing. And once again, the dose rate is going to depend on the type of fruit and processing conditions, such as your contact time, your pH, and your temperature. If you need any help with any of these steps, or just please contact your Gusmer rep and we can work with you.
Thank you, Maureen.
You're welcome.
And with that, we'll turn it over to our next presenter. So Mike Majurko is our product manager for brewing technology, responsible for our brewing equipment lines. Prior to that, Mike was a technical sales rep for the Midwest for Gusmer. A lot of you on the call today have probably encountered Mike somewhere or another. He has, background working as a brewer at Rock Bottom Brewing in Minneapolis. I had the pleasure of working with Mike previously as brewers at Summit Brewing in St. Paul. Mike also went on to start up his own brewery, Mankato Brewery, where he was the head brewer. And then he was instrumental in building out and commissioning the brewery at the RARS Technical Center in Shakopee, where he was the head brewer. And he also worked as a product manager and technical support for BSG before coming back to Gusmer as well. So with that, I'll turn it over to Mike to talk about some of the processing equipment we recommend for seltzer production.
Thanks, Nate. Hi, everybody. So yes, we are fortunate to have, as part of our offering, processing equipment from Denwell. Denwell makes a wide variety of processing equipment for the cold side in the brewery, some of which is also particularly well suited for seltzer production. Kind of one of the things we wanted to start off talking about here today is deaerated water. Deaerated water is probably one of the more useful things that you could put into your brewery if you don't already have it. And if we're going to talk about seltzer and or high gravity brewing, it's both a utility and an ingredient. One of the bullet points you'll see on here is that once a brewery has it, they'll wonder how they got by without it for so long. Deaerated water not only can it be used to mix with your alcohol base, then to add flavorings, etc., to create your seltzer. It could also be used in many other applications, from pushing a centrifuge bowl, or pushing out a filter, or just pushing brewery lines with something that's not going to contribute unwanted dissolved oxygen to your beer. Denwell has a number of different pieces of equipment for this. Probably the most effective and one that we like the best is this Denwell water deaeration column cold. And yeah, it has a bunch of different features that you can add on to it, like UV sterilization, precarbonation, and chilling, depending on what your water source is. This is not a problem for a lot of brewers, but if you're in a place where the groundwater or whatever the city water is never gets really cold, it's nice to have it be able to be chilled down to something closer to what your product temperature would be. Another type of technology that Denwell offers is gas injection. And Denwell offers gas injection for pretty much any gas that you would use in the beverage industry. You know, from either aeration, oxygenation, or both, if we're talking about making sure that our wort or our seltzer base has the right amount of dissolved oxygen to help promote yeast growth and metabolism in the early part of fermentation. And then also for carbonation in line to carbonate our seltzers or beers, or even nitrogenation, depending on what you're doing in your brewery. Denwell also offers several different levels of automation available in this equipment, from something that's very manual, has manual valves and media input and product input output, and then gives you instructions on how to set these valves based upon the flow rate and the temperature, et cetera, that you have to work with, to semi-automated versions, which are ratio controlled, where you have a bit of automation controlling regulating valves that change the dosing and the speed of either your product flow or your gas dosing, to fully automated and analyzer controlled units that have an analyzer, whether that be an oxygen analyzer or a CO2 analyzer, et cetera, that is then working to give feedback to those ratio controlled automatic valves to make sure that you are getting exactly what you want out of your beverage and your gas injection. Another thing that we can do here is to take that carbonation or that inline gas injection, especially with regard to carbonation, one step further and include a blender in it. And so this particular piece of equipment can be used to blend your seltzer base with your deaerated water stream and then carbonate it all at one time. This unit can either blend alone, carbonate alone, or blend and carbonate together. And the other thing I would mention too, in addition to this, should you already have inline carbonation in your brewery but are interested in the blending part of the technology, Denwell does also offer a standalone blender. One of the things we talk about when we are making seltzer is adding the flavor to it. And so Denwell does offer inline dosing equipment that could be used for this purpose. You know, again, this is a piece of equipment that could have multiple uses in your brewery. You know, whether you're making a shandy or a radler, in addition to your seltzers or other sort of flavored type beverages, this would be a unit that you could employ to help produce those types of products. And each one of these pieces of equipment is essentially going to be customized because it is able to be adjusted depending on what your needs are. What the flavors are that you are producing or using in your process, whether they would be prepared liquids or whether they would be coming from a powder and would need to be prepared into a purged dosing tank. Denwell can offer any option for that and in any number. So if you only need to add one flavor of one type, that's fine. If you need to add multiple flavors of different types, that's also a possibility. Other important thing, depending on what your process is and what your ingredients are, you may need to pasteurize your product before it goes into packaging. Denwell also offers flash pasteurization equipment. Their flash pasteurization unit is fully automatic. Basically, you enter the values that you want out of your product in the end, and the machine does the rest. While there might be different levels of automation and other pieces of equipment from Denwell, Denwell feels that pasteurization is probably best left to automation. We are all very fastidious people and always pay the closest attention when we're dealing with our product, but we're all ultimately human. And if we're concerned about the safety of our product, it's best that we have automation handling that. So in short, maybe something if you are using raw fruits or you know, fruit pulp or whatever you're using to flavor, you may wish to make sure that that is completely microbial neutrally, so that you don't see any type of re-fermentation or any other type of, you know, whether from yeast or other pathogens or microbes in your product by the time it gets to packaging. Finally, what we have to talk about is the Denwell Seltzer system. This is a relatively new concept from them that's just come out in the past month that we've quoted to 1 or 2 customers before. And as a colleague of ours in the sales department says, this isn't a piece of equipment, it's a business plan that arrives in a sea container. And so what you could think of this piece of equipment as is sort of like your rack stereo system where you've got you know, your tuner and your receiver and your tape deck and your CD changer are all mounted into one unit. And that's what this is. So we have a combination equipment skid that incorporates derated water with pre-carbonation, and then a carbo blender and flavor dosing all at one. So basically you would have the inputs of your base, and the rest of it would be taken care of by the skid as far as to then ultimately ending up with your flavored carbonated seltzer coming out the other end. So essentially everything you could potentially want to make the base, all on one skid. As I mentioned, it's relatively new. Basically right now we're treating them as customized pieces of equipment, which they would ultimately be depending on your need to dose flavors and how many different types, etc. But they are in the process of developing a standardized size and standardized design for the unit. So at this point, we can handle it as a custom, but ultimately will be standardized.
Perfect. Thank you, Mike. And with that, that concludes our presentation today. So we're going to open it up to questions. All the presenters here will be able to answer any questions you have. And then just a reminder, after the presentation today, if you want any additional information or pricing, please go to our website, gusmerenterprises.com. Go to that Find a Rep section, type in your information, and you'll be connected with your local technical sales rep. So Chris, what's the first question you have for us today?
So the first question that I have that came in is, please explain the killer status, the pros and cons.
Yeah, good. I can do that.
I'll let Peter take that.
Yeah, so killer toxins is a weird phenomenon, but it's characterized by a lot of microorganisms that under certain growth conditions, they excrete toxins that kills surrounding microorganisms. You see that very often in the fungal world. So everyday mushroom you eat for dinner, if you grow them under suboptimal conditions, they are very toxic to you as well. So for Saccharomyces cerevisiae, it's the species that is most characterized with its killer factors. And they have 3 groups, K1, K2, and K28, and they have different killer properties. So they can excrete the toxin and be immune to their own toxins, and that can attack other Saccharomyces cerevisiae strains or related species to Saccharomyces cerevisiae. So basically, it's just trying to get all the goodies on its own. I would say in hard seltzer, it wouldn't be a problem because you're only adding one single strain. So there's nothing for that yeast strain to kill. So even though it excretes it. And when we talk about killer neutral strains, it means that they do not excrete toxins for various reasons. Often they are mutated and can't do it, but they are often also immune to some of those toxins. So, but for hard seltzer, I wouldn't say that's an issue. It's more if you have a brew with different species you want to make, or you are in a winemaking environment where you want more of the non-Saccharomyces flavor impact.
Yeah, thank you, Peter. And just to add to that, when we're talking about high gravity brewing with the yeast strains we talked about earlier today, the yeasts are going to be put under such harsh conditions that you're not going to want to repitch from them anyway. So the killer status is not really a factor in high gravity seltzer production.
Tom, I hope that answered your question. If not, please reach out to us. The next question, do I need to pre-acidify my base before inoculating with yeast?
Yes, I can take that, Chris. So it really depends on the strain of the yeast that you're using and what the optimum pH for that is. I think overall, looking at it, optimum pH would be 4 to 6. And if it really, and it also really depends on your protocol. And so if it is not within that, then yes, you can pre-acidify prior to inoculation.
David, I hope that answered your question. Moving on to the next one. This one is for Mui. Could you centrifuge the base to perfect clarity like we do our beers, and then add loose carbon and centrifuge again to remove the carbon?
If your centrifuge is able to remove loose carbon, and I'm not sure what type of centrifuge you have, yes, you could. You could definitely centrifuge your base to perfect clarity and then add loose carbon, remove any off flavors or aromas or color, and then centrifuge again to remove the carbon.
Perfect. Again, if you guys need additional answers, need additional clarification, feel free to reach out to us in chat or Q&A, and we can add to that. So the next question again for Mui. I'm just curious on the timing of applying pectinases to the process.
So if you are using any type of natural fruit juice or puree that hasn't been treated with pectinase, then you want to treat the juice or the puree with pectinase prior to adding that as a flavoring or whatever it is that you're going to use into your seltzer. This helps to pectinize your juice or your puree. That way you deal with less filtration issues at the end, because once you add that product into your seltzer for flavoring, it does throw the equilibrium that you built in that seltzer off balance. So you could have something that either comes out of solution or something else that needs to be filtered out. So treat the juice and puree prior to using, and then add it to your seltzer, and afterwards you may or may not, depending on what you have in your seltzer, need to filter again just to get it to be more clear, if that's what you're looking for.
Neil, I hope that answered your question. On to the next question. Should there be a target pH post-boil and post-fermentation?
I can take that, Chris. Should there be a target pH? I guess I'm going to go back to the first question and answer to that. It really depends on your yeast strain that you're using. Optimum pH again is 4 to 6. Now keep in mind the pH will fluctuate throughout the fermentation. So if your general protocol is that you do adjust pH during fermentation, then yes, continue on that protocol. As far as a recommendation, I would say it's an optimum pH would be 4 to 6. Keep it within that range, and also pay attention to the pH of your yeast.
Perfect. I'm going through these. We're getting a lot of questions. What is the relative sensitivity to O2 in seltzer versus beer? I've noticed anecdotal that packaged seltzer appears much less susceptible to TPO. As a follow-up, is DA water absolutely required, or simply a good idea to follow procedure usually applied to beer production?
I can say from for the yeast physiology, the oxygen is not a problem. The yeast can easily handle the oxygen and will consume it. But if the question is related to quality, I think Nate or Mike might be the better to answer that question.
Yeah, I think that's going to be dependent on what your starting gravity is and what you want your packaged product, either ABV or CO2 volumes to be. Typically, you know, what we've seen for packaged products, CO2 volumes are on the high side as compared to beer. So, you know, 2.6 to all the way up to 3 volumes. So a very spritzy carbonation, you know, flavored mouthfeel throughout. If you can achieve that without additional process equipment, great. You know, you can still do CO2 adjustment in your bright tank with a carb stone, doing it the old-fashioned way. What we're presenting with our Denwell equipment line is if you're high gravity brewing seltzer and tank turnover and you know, decreasing your production time is important to you, we have the equipment and tools in order to achieve that.
And I wanted to add too, I'm not really a seltzer production expert by any stretch of the imagination, but as far as dissolved oxygen content in your product, the answer is how important is it? It probably depends. And it probably depends on what your process is and maybe what some of the other ingredients you're using are. And whether or not you could end up with some flavor or color degradation in your final product over the course of its shelf life, depending on what that DO level was.
Great. All right, moving on. We've got a few more questions. If given the option, would there be a fermentation benefit to use either dextrose or sucrose? Would sucrose exert a lower osmotic pressure?
Jasmine, I'll let you touch on this too, but certainly it's going to be the purity of the sucrose and dextrose you're using. So we've seen there's all different grades for the two out there. So that's something when you're reaching out to your raw ingredient suppliers to make sure to check on that. Also, if you're using any organic sucrose, organic sucrose has a much higher color and particular content as opposed to clarified sucrose. So it's going to be dependent on your raw material.
Perfect. Moving on, are there particular microorganisms one needs to control for in seltzer making process, especially if not pasteurizing?
Yeah, Peter.
Yeah, there's always a chance that there will be other organisms in it. But of course, if you try to boil it as much as you can, all your pre-treatment of the seltzer base, you will eliminate as much as you can. Of course, you're not purely sterilizing it. So it all depends on your equipment downstream, I would say. So you have your fermentation vessel where the Saccharomyces cerevisiae will be dominant and suppress a lot of the other indigenous bacteria and yeast. But of course, downstream from that, if you don't sanitize properly, there will be risk of contamination. But if you're not repitching, as Nate was recommending, you're minimizing your risk here.
And I think at the start of fermentation too, Peter touched on the importance of yeast rehydration, yeast reactivation in order to get that fermentation lag phase reduced and going quickly. That'll certainly help reduce any micro contamination that you may have in your base. Keep in mind, if you're working with sucrose or dextrose, you're working with very simple sugars. So if you don't have proper cleaning and sanitizing process in place already, you're opening yourself up to more exposure.
To that, I would say, again, probably also depends on your downstream process and the other ingredients you're using too, as far as if you're back sweetening this and what types of flavors, how they're derived you're adding. You need to keep in mind all the pieces of equipment that this product will go to ultimately before it ends up in the filler, and what type of nutrients are available for microbes that either you knew were there or that you never intended to be there to consume once it's in the package.
Great. I think that also, I know Jamie asked, can you repitch the yeast or is it a one and done? I didn't know if you guys wanted to go into, I know you just answered some of it.
Yeah, just to touch on that again, with the 3 yeasts we're recommending here today to achieve a neutral flavor profile and at high gravity brewing, you would not want to repitch them.
Great.
Those cells are done. They have been on a hot journey, and achieving high alcohol percentages is definitely also having an impact on their viability for further repitching. Definitely not recommended.
So Brandon had a follow-up question, and since we're still talking about yeast, considering the question of dextrose versus sucrose, I was hoping to get an answer more related to yeast physiology. So the preferences and stress and things like that.
Yeah, good question. I think, sucrose is a glucose and a fructose dimer. So and that's what yeast are very much used to in wine settings. That those two sugars. I don't see any particular difference in the on osmotic pressure on them, because again, if you are treating them well on the rehydration reactivation step, they're pretty tough cells. So I think it's more to make sure you have the proper nutrient in as well, to make sure that they can support the generations that is needed to complete the fermentation. If you need more details on the osmotic pressure differences, I need to look it up and we can have that conversation offline. You're more than welcome to contact us.
Great. Lots of questions still remain. So how much earlier do you recommend adding the ALCDC prior to adding yeast?
We recommend adding the ALDC either at pitching or just slightly before you start to pitch. Keep in mind, the reason we're asking you to do that is the yeast the organisms are going to produce those precursors that bring the VDKs out and could impact your beer quality. So you want to go ahead and add the ALDC before you pitch or at pitching with yeast. You don't want to add it after you've pitched your yeast, because then there's a chance that the diacetyl has been already introduced in your product. So there's no way to get rid of that other than just to let it go through the natural rest that's needed.
Thank you, Mui. So 3 more questions. Can anyone identify the approximate ratio of packaged draft seltzer being sold in the market? Are there concerns with draft line cleaning and maintenance when switching between flavors on the same draft line?
That I don't know if anyone here on the panel today is versed in that. So I think certainly anytime you're adding flavors into a packaged product, whether it be cans, bottles, or draft, and then draft in particular, where you could possibly be sharing lines, if that draft isn't flash pasteurized or neutralized, yes, there's potential for flavor crossover and color crossover there.
Yeah, I mean, I think we've probably all had that experience when we've been out in the pub and we've ordered a Pilsner that was being served from the same line, and the last beer on it was like Pete's Wicked Strawberry Blonde or something like that, and suddenly your Pilsner tastes like strawberries. So, I mean, I'm sure that has a lot to do with the types of flavors that you're using and the concentration. But I think it's always a good idea if you've got a flavored product line, either of course to thoroughly clean it afterwards, and then maybe have that be a product line that is dedicated to flavored products, just from my own personal experience.
Thank you. 3 more questions. Any thoughts on vertical versus horizontal tanks?
I mean, from the yeast physiology, depending on the size of the tank, of course, but I'm not expecting you're using 100,000 gallons to make the hard seltzer. But if that's the case, there is some engineering aspects to it, but in general, not an issue from the yeast point of view.
Okay, Peter, don't mute yet. Would you recommend the same yeast for wine-based hard seltzers?
Yes, these 3 strains that we recommend here is selected for various reasons, but they are all very good fermenters and they can sustain a lot of alcohol. So they are used in wine making as well. So yes.
Okay. Could you provide a recommendation for low alcohol production, yeast strain, pitch rates, nutrient selection, and dosage?
Yeah, we do have that information available in our hard seltzer handout, which if you go to our website, gusmerenterprises.com, and go to the Find a Rep section, you can contact your local rep and we can hook you up with those yeast nutrient and yeast dosing guidelines for lower gravity production as well.
Thank you. I think we have 1 question left. When blending the sugar base, is RO water recommended?
I would say from the yeast again, RO strips it for some essential trace minerals. So if you have a good water source that has no chlorine in it, I would say why not go for tap water? But for other reasons, you might want to use RO if you have very hot water, or for other reasons, especially highly chlorinated tap water.
I would say if we're talking about further downstream, when you've already got your base produced and you're going to make your final product, that you would want to, I mean, RO would be ideal, but I think the main things that you're going to want to pay attention to are what are the flavor contributors in your water. Is it chlorinated that you would want to remove at the least? Do you have, you know, either high mineral content or an iron issue? Probably as long as the water is you know, clean, potable, and doesn't have a lot of flavor constituents to it, it should probably be okay. Of course, you know, if the dissolved oxygen of it is not going to be a problem in your process, depending on what that is and what other ingredients you might be using.
And that is all the questions that we have.
Well, thank you, everyone. And again, I just want to thank all our presenters here today. Peter Stenford for setting this up, and Chris Nevash for being our moderator behind the scenes. So again, if anyone has any additional questions or would like more information or pricing, please reach out to your local technical sales rep.